Okay. Yes, now Arinda, I can see you have raised your hand. That is good. You've located it, right?
I've got it, sir.
Okay. Ekisa, have you also got how to raise your hand? Yes, you have. Great. Lovely. So that's where you'll find the tools in case you want to interact, in case you want to make contributions. So I'll be able to see that you've raised your hands and then pick. Okay. Now I'm not seeing other people joining. I don't know what's happening. So Ekisa, you could just be telling them that they need to join. I just informed them in the group.
Okay, let me call them. Let me call some of them.
Yeah, Joan is saying that she's not understanding, but I had shared it. Did you download Teams using the link I shared?
For me, I just downloaded from the Play Store.
From the Play Store.
Microsoft, then I put Teams, then I downloaded.
Okay, all right. Shamira, what has happened to you? Let me admit you again. Okay, so I'm going to test sharing my screen with you and then to see whether you can see my screen. All right, Nabi, you're welcome. Can you hear me? Shamira, can you hear me?
Yeah, I
Okay.
can hear you.
Good. That's nice. All right, thank you. Okay, let me share my screen again and see whether you can all see my screen. Right, that's what I want to share. Okay, are you seeing my screen where there is solving inequalities up there?
We are seeing.
You are seeing. Very good. Okay. How about X, are you back?
Yeah, I'm seeing the spread. So
okay, very good. So that's what we are going to talk about. The last time we were in class. So now, Ekisa, you can switch off your microphone. I think it's giving me feedback. Yes, that's better, so that everybody can hear. If you have a comment, you put up your hand. It will help me to see that your hand is up, and then I can easily pick you. Yes, so I am briefly today, let us look at the main features of inequalities. I will be using a highlighter so you're able to see what I am talking when I highlight something. I am going to explain. I will use a highlighter so you can focus on that item I'm highlighting. Yeah, so I have just a moment, I need to do something here.
Excuse me, sir.
Yes, please.
What if you want to download the? What if you want to download them? Where do I go?
If you want to download what?
What you're talking?
What I am talking there? Oh, this is on my computer at the moment, because the caucus, when you go to caucus or to the LMS, the feature, I'm not using the LMS at the moment because the caucus for live class is off. That's why I was not able to schedule the class. So I'm using the handout which is on my machine, but it is also there in the LMS anyways. There is the link. There's a document I have put which is the same like this one, which is called Inequalities handout. If you log in there, I think you should be able to see it. So you can
meaning
get
downloading your audio.
downloading my audio. What I'm
you're
talking. Oh, no. I will have to record. I'm recording this session. Then later, maybe I'll share a link for you to be able to get it.
Okay, sir.
Yeah, I'm recording it, so don't worry. You'll get the video for this. Yeah. I'm told some people are here. Let me just get them in. Right, Naviri got out again. Okay, I think she's back. Right, so let's get back to the share. I hope are you okay? Are you still seeing my screen?
Me, I'm seeing it.
Okay, good. So inequalities deal with symbols. The symbols of inequalities are here. I'm going to, as I said, I'm going to just do a highlight so that you can see. It deals with greater than. So I'm highlighting this. Are you seeing what I have highlighted?
Yes, we are seeing.
Great. So inequalities deal with symbols which are greater than, less than, greater than or equal to. When you see greater than and a dash down, it means greater than or equal to, and then less than or equal to. So meaning for linear equations where we are using the sign of equal to, now we replace the sign of equal to with the inequality sign. So it can be the left hand side is greater than the right hand side, or the left hand side is less than the right hand side, or greater than or equal to. So these are the four symbols you use for representing inequalities. Now for linear equations, we solve for a definite value. Say x is equal to, you remember that. But now for inequalities, we will have something called a range. Let me highlight this next one, a range of values. Have you seen what I've highlighted? Yes?
Yes.
Okay, so we will be dealing with a range of values instead of just a single value, because the unknown now takes on so many values. Illustration, you could have something like x plus 3 is greater than 4.
Yes, I see. Searching for network.
Sorry? Somebody has a problem? Hello?
Maybe I'm okay.
I'm hearing somebody saying searching for network. Is somebody having trouble?
Maybe I'm okay.
Okay, let me just be sure that my how about others? How are you guys? Arinda, are you fine? And Naviri, are you okay there? Yes, Arinda, Naviri, are you fine? Are you hearing me?
I am hearing you. I don't know how others.
Can
you hear me?
Yes, but I can hear you. I can hear you very well. Okay. Right. So I'm explaining about the range. Let me pick an example. So when we're dealing with inequalities, we have, instead of having a single value as in the case with the equations, linear equations, for inequalities, the unknown, say x, can take on a range of values that can satisfy it. I was saying you can have x plus 3 is greater than 4, for example. Now you will solve it in the same way you solve linear equations. The only difference is that now you don't have equal. In your mind you must have greater than if the symbol is greater than, or less than if the symbol is less than. So where you were going to deal with the inequalities, we can solve simple inequalities using the normal methods. We can also solve simple inequalities by drawing graphs, and when we're drawing graphs we will be shading what we call wanted and unwanted regions, and then we can use what we call modulus. I'll explain that shortly. And then inequalities can also be quadratic. So if they're quadratic, it means the power is 2, the power of the unknown is 2 instead of 1. So there you will get what we call a quadratic. Yeah. So let me see, somebody is trying to join. Let me first get people, check who is on. Arinda had been kicked out. Let me see. All right. Okay, Lois is also coming in. Let me just admit more. All right, so Lois and yeah, Lois, you're welcome. Can you hear me? If you can hear me, tap on the microphone and say yes, you can. Lois, can you hear me? There's a microphone at the bottom. You tap on it, Lois, so you're able to unmute yourself and then you can talk. Okay, Lois, I'm still waiting for Lois. Arinda, you dropped off. Are you back on now? Can you hear me?
I'm hearing you, sir.
Okay. Asege, Lois. Lois, if you can hear me, just make a comment so that I can know that you're with me. All right, Shamira, are you also still here? Are you hearing me? Oh, Lois has dropped off. Shamira, can you hear me? Right, okay. Let me just speak where I stopped. Ekisa, your microphone is also flashing. Are you hearing me? Are you having challenge?
No, I'm getting you very well.
You're getting me? Yes, I can. I can hear you very well too. Okay. Yeah, I'm back to here. I was talking about solving linear equations, linear inequalities. You use the methods like we used a method of algebra, using the similar method of solving linear equations, only that instead of using equal sign, you use inequality sign. Second option is to plot graphs. You can plot graphs. And then the third one is using what we call modulus. In this particular case, that means the inequality may have may be taking on negative and positive values, so that's why you use modulus. And then the inequality can also have a power of 2 for the unknown, in which case it becomes quadratic. We shall look at that later after we have looked at quadratic linear equations. Right, so today we will, yes, let me come back here and we look at the introduction. Somebody is coming in. Let me allow them back. All right. Okay. Let me ask us, Lois again. Lois, can you hear me now? Lois, can you hear me? Yes, Lois, are you hearing me? Okay. Lois, can you hear me? I thought I had her speak. Okay. The microphone. Okay. Let's we'll get there. Okay. So here is an expression. I would like us to look at this expression. I'm highlighting it. If you can see what I've highlighted, I want you to say yes, you can see. I've highlighted that. Do you see? Yes.
Yeah.
You see what I've highlighted?
Yes.
Okay.
We are seeing.
Very good. Right. Joanne has also joined us. You're welcome, Joanne. Right. So I have 5x minus 4 is greater than 2x plus 3. So that is what we call an inequality. So the left hand side is 5x minus 4. The right hand side is 2x plus 3. Okay? Now, our task using the algebra method is to ensure that the unknowns are on one side and the constants are on another side. So we solve using the same method of solving equations. The only problem, or the only different thing, the only problem. Sorry, who is speaking? Joanne, are you the one speaking?
She's the one.
You want earphones, huh? But I can hear you. Okay, good, Joanne, you're welcome, okay?
Thank you, sir.
All right, so I can see you are here, and we are on inequalities. Lois, I'm still waiting to hear from Lois whether she can hear us. But it's good I can hear. Joanne can hear me. Lois is still not talking. Right. But as we proceed, so I wanted you to see, I've shared my screen. I don't know who is speaking now.
Sir.
Yes, please.
Now, how can I connect to my laptop?
Who is asking? Let me see. Is that Joanne?
That is John.
Yes.
Joanne, you need to be you need to have Teams also running on your laptop. Okay. You have to download Microsoft Teams on your laptop for you to be able to use. It's like an app. The same way you have downloaded on your phone, you also download on the laptop. You cannot broadcast. Okay. Right.
Okay, sir.
Okay, so you can mute. Joanne, now you mute yourself so that you can hear me properly. In case you have a question, that's when you can now unmute, okay? Tap on the microphone to mute it. Okay, good. You have done that. Lovely. So you unmute only if you want to say something. If I have asked you a question, you want to contribute, then you unmute. Yeah, so I was talking about this inequality 5x minus 4, which I have highlighted here. 5x minus 4 on the left hand side, right hand side is 2x plus 4. So that's how any inequality looks like, and I've already talked about the key points here: greater than or equal to, less than. These are the symbols we use. So in order to solve, now I'm coming here, in order to manipulate, to solve inequalities, the steps are the same like we did with, we use similar rules. I've said that, I've highlighted that. So you follow similar rules. The only exception is that you can use inequality sign instead of equal sign, right? So first you add the same number to both sides of the inequality sign. Step number 1 here, very important. Add the same number. Okay, when you add the same number, it remains the same, right? When you also subtract, it's the same, but there is something that changes. Very important, note this. If you multiply or divide both sides of an inequality sign, note this one here. Let me highlight that again. Right, there you go. Here. Let us see this one. If you multiply both sides of an inequality sign by the same positive number, the inequality remains the same. But when you multiply by a negative number or you divide by a negative number, the inequality sign changes. So all these, whether you're adding, it remains. Whether you subtract, it remains. When you multiply by a positive number, it remains. But if you multiply or divide by a negative number, let me highlight that. I'm going to this is important. I'm going to do a color change. There you go. So when you multiply or divide both sides of the inequality sign by a negative number, the result of the inequality is no longer true, and then the sign must be reversed. In fact, the inequality becomes reversed. So previously, if it was greater than, it must change to less than. If it was less than, it changes to greater than, in a situation where you are either multiplying or dividing by a negative number. So these are the rules for dealing with inequality. Similar to linear, the only change is here. So let's see. I want to just pick quickly to look at some examples, very basic examples. Example number 1. Okay, suppose we have to solve the inequality x plus 3 is greater than 2. So we have to subtract 3 from both sides. Remember, you use the same approach. You must subtract 3 from both sides, so you have x plus 3 minus 3 should be equal to 2 minus 3, and the result is x is greater than 1, negative 1. Now remember, I said that for inequalities, the unknown is a range. You don't get a single value. If it was equal to, you'll get x is equal to negative 1. But now in this particular case, it is not equal to. It is greater than. So you have all values of x greater than negative 1 satisfy this equation. So you will not have a single value but a range of values. And if you are to represent this on a number line, that is how it will look like, from negative 1 all the way across. That is your x is greater than negative 1. That will be the solution. So x is equal to 0 is a solution, x is equal to 1 is a solution, x is equal to 2 is a solution. So that is something that I want you to pick here. Now I'm going to involve you right now. I would like you to solve this one. I'm not exposing the whole of it. Solve the equation number 2. 4x plus 6 is greater than 3x plus 7. Are you there with me?
Yes, we are there.
Are you with me?
Yes, sir.
Okay.
Yes, sir, we are there.
Okay, now maybe let's first go through it step by step. Now here, first step is to subtract 6 from both sides. Okay, so on the left hand side you have 4x plus 6. Now you take away 6, you'll be left with 3x plus 7. Take away 6, you're left with 1. Are we together here?
Pardon, sir.
If you subtract both sides of the inequality, subtract 6. Are you with me? If we subtract 6, on the left hand side you are left with 4x, right?
Yes, sir.
Then on the right hand side you'll have 3x plus 7 minus 6. You'll be left with 3x plus 1. Is that okay? Then next step, now we subtract also 3x, meaning we want to bring 3x to the side of 4x so that the x's are on the same side. So I'm subtracting now 3x from both sides. So you will have 4x minus 3x on the left hand side. On the right hand side you have 3x minus 3x plus 1, so you'll be left with 1. So 4x minus 3x, you have x. So the final solution is x is greater than 1. That will be your solution. We call that the solution. And if we are to represent it on a number line, that is how it is. Now where the number 1 is not part of on the number line, you see here you have a circle. Okay, you start from 1 but 1 is not part, so you put a circle. But if 1 was part, if it was x greater than or equal to 1, then you will shade the circle. It will be a full, you will not have white in here, because 1 will be part of. So now it's any x value from 2, 3, 4 and so on will be a solution to this equation. Is that clear so far?
Yes.
Okay, now you're going to do the next number. The next number is for you to try. Number 3. Okay, number 3 is here. Number 3 I've highlighted. Solve 3x minus 5 is less than or equal to 3 minus x. Can you do that now? Do that and you tell me the answers. Attempt that somewhere and you tell me. Let me hear that. Right?
We have got x is equal, sorry, x is less or equal to 2. That's what I've got.
That is Shamira?
Yes.
You've got x.
X is less or equal to 2.
X is less than or equal to 2. Herbert?
That's what I've got. Yeah.
Okay, thank you, Shamira. Next, who else? Herbert, what have you got?
I'm still working on it.
Okay. Joanne?
I'm working on it.
Okay, let me give you a few 2 minutes. 2 minutes. Okay, are we almost there?
I've got x is less than or equal to 2.
X is less than or equal to 2.
2.
I got is less or equal to 4.
X is less than or equal to 4.
Yes.
Okay. Now Shamira, yours again. Give me, Shamira.
I've got x is less or equal to 2.
Less or equal to 2. Arinda has got the same. Yes, Ekisa, you're saying yours is
less or equal to 4.
Less or equal to 4. Joanne, where are you?
I found there is less or equal to 2.
Yours is less or equal to 2 also. Okay. Lois is not speaking. Lois, are you there? Can you hear me, Lois?
I'm there, sir.
Ah, finally. Great. Good to hear you. What have you got?
I've not yet gotten any answer.
Where have you reached?
I'm still trying.
Okay, we give you 1 minute.
Okay.
Now, also what to?
Hey, Herbert has changed his mind.
No, I had made a mistake. I crossed the x this side and I kept it negative. I just realized.
Okay, good. So this is 3 minus x. Right, so okay, so the principle is you're dividing 4x by 4. Yes, so the answer is true. It should be x is less than or equal to 2. Okay, everybody should get that. So let's come here and check. Yeah, so there we go. We start by adding 5 to both sides, then we add x to both sides also, and then finally when we get 4x is less than or equal to 8, we divide both sides by 4 to give us x is less than or equal to 2. Now notice, if you are to represent this on a number line, you notice earlier I had said, let's check the difference. The earlier one, this circle here, for x is greater than 1, is white inside. That means it's not shaded. Are you seeing the difference?
Yes, we are seeing it.
Yes, so there, that means 1
Yes,
is not
sir.
part of. Now with this one where you have less than or equal to, now 2 is part of the solution. Do you see that? So where 2 is part of the solution, now the circle is shaded, it's all bold, it's all black. So that means 2 is part of the solution. If you are to list the solution set, you'll have 2, 1, 0, -1, -2, and so on in that direction. So that is our actual solution. So the closed circle denotes that x can actually be equal to 2. It means the solution begins with x is equal to 2. In the earlier one, the solution 1 is not part of the solution. You must look at a number that is greater than 1. Okay?
Yes.
Great. Now let's look at a third one. I want one where you have now dividing by a negative. There we go. So if we are supposed to solve this equation, which is an inequality, negative 2x is greater than 4. So the last point I emphasized in the points and in the approach of solving equations is that now here we are dividing both sides by -2. So dividing by a negative number or multiplying by a negative number changes the inequality sign. From greater than, it changes to less than. Okay, so that's something that is important. The reason is now you have changed that number to a negative, so it has to reverse, because it will not be true if you leave it the way it is. So in order to solve this, you divide both sides by -2, and then we need to remember that we are dividing by a negative number. The inequality sign must be reversed. What does that mean? Initially we had -2x is greater than 4. So having divided by a negative number and I got in a -2, it becomes x is less than. So the inequality sign must change whenever you are dividing a number or multiplying a number by a negative sign. So that's the principle you should not forget. Okay? Okay, are you
I have
all with
a
me?
question.
You have a question, please go ahead.
I have a question.
Yes, please. Yes.
What if the question was negative 2x greater or equal to 4? The sign changes to what?
It still changes to less than or equal to. because you have greater than or equal to. Then if it changes, it becomes less than or equal to. Okay.
Okay, sir.
All right, great, good question. Okay, so let's look at a few more illustrations here. I think I need to just go straight to our illustrations now. Exercise, good. The exercise numbers here. So you see the exercise numbers. Here we are supposed to draw. I do not want to do the drawing yet. I'd like us to get the solutions. Go to get solutions, right, to solve. That's number 2. Right, so number 2 here. Oh, sorry. Yes. All right, Albert, go ahead. Yes.
How do we represent this x is equal to negative 2 on a number line?
How do we
represent this with the number we just did, the final number of x is less than negative 2. How do we represent on a number line?
X is less than negative 2.
Yes.
Okay, so x is less than negative 2. You draw your number line. If it is less than, you draw your number line again. With the number line must have both. You must move from 0 both to the left and to the right. Okay. From on the left to the left is negative numbers. To the right of 0, positive numbers. Okay. So if it is less than a number which is less than negative 1, it means it must be more negative. You must see as the number must be more negative, isn't it? Now negative 1, when you compare negative 1 and negative 2, which one is bigger?
Negative 1.
Negative.
Negative 1 is bigger, yeah? So if negative 1 is bigger, okay, if negative 1 is bigger, that means if you are talking about x is less than what? Negative 1.
Negative 2.
Sorry? If x is less than negative 2, that means on the number line now, any number to the left of negative 2 is less than, isn't it? So negative 3, negative 4, negative 5. So to the left, the numbers which are more negative are smaller. Is that clear?
Yeah.
Yes. Okay, so that's how you will represent it on your number line. So numbers which are more negative are definitely smaller. Okay, so that's how you would put it on the number line. For example, here, if let me just use this number line on E. Are you seeing number line on E here? Let's actually here, let's use this. Okay, give the inequality. Let's use number 2. Give the inequality which produces the range shown in the figures below. Okay.
Yes, number 1 would be the A would be x less than negative 5.
No. Somebody
Yes,
try.
Number 1 would A. A would be B. X less than or equal to negative 5.
Exactly, because it is bold. How about you missed this out? 5 is part of. Okay. How about, are you with me?
Yes, I'm with you, sir.
So 5 is part of, so it will be x is less than or equal to negative 5. How about B?
B is, this is x is greater than
X is greater than 2.
X is greater than 2. X is greater than 2. That is very good. I'm going to skip C for now. We go to D. I know why I want to skip C. Okay, D. How about D?
D is x is less than 2.
X is less than 2.
Joan, is that Joan? X is less than 2?
Yes, sir.
Okay, good. Lois, I'm not hearing Lois's voice. I want to see Lois. Lois, where are you? Don't get lost.
I'm here, sir.
Right, Lois is here, and we have welcomed somebody new. Joseph has just joined. Joseph, you're welcome. So I am happy that we are getting the concept right from the figures. Now, D and E are similar to lying in between. Do you see C, number C here in number 1, number C?
Yes.
Right, so this is where now X is lying between values. Do you see that?
Yeah.
X is lying, so it is not indefinite, but now X lies between values. So for example, for C, you would be drawing that X is lying between -1 and +2, but with the 2 inclusive, while -1 is not part of. Do you see that? So if we're to represent it somewhere on this number line, I'm just using let me use this number line which is already represented here, but we're using our own now. So you will start from here. You'll start from -1 here, okay, but with a what? A circle that is not shaded, and then to 2 with a circle which is shaded. So that means our X here is lying between 2 and -1, but -1 is not included while 2 is included. Have you followed me?
Yes, sir.
So between -1 and 2, but 2 is part, -1 is not part. So that's the meaning of C. So if we are to look at C now, at C, who should tell me this? Arinda, you tell me this. So how would you what would be the equation that give the inequality which produces this result? C. Remember, this one means X is lying between 2 values. Okay? Arinda, are you there?
I'm there, sir.
So C, how would C look like?
-5 is -5 is less than X greater than 2.
Sir, -5 is less than or equal to negative.
Mine is right.
0784.
Oh, who is giving a phone number?
63.
Okay. Who is Arinda? Your hand is still up, so I don't know. You want to contribute again?
No, I wanted to ask for something.
Okay, go ahead.
On number 1C.
Number?
On number 1C.
Number 1C. Okay, number 1C. Yes.
Where they have said draw the number line representing each of the following, but now what if they say sort of it the way it is? Do you cross to the other side? -2, -1 this side? Oh.
Here you can't solve. It's already, this is like a final representation. So there is no way you're going to say you're going to solve. You're already told this is like a solution. Yes, this is a solution. So here you are not solving.
So they can't say that sort of in the case. They say sort of.
In this particular case they can, because what are you solving? It's already there are no other numbers. So it's this is really a solution set already.
Thank you, sir.
Yes, it's a solution set. Your task is just to represent it on a number line.
Okay, sir.
All right. But if there was a modulus, later on we shall see the modulus. If there's a modulus, then yes, you may be required to solve. That will be later. Okay. Where were we? We're still on what?
Number C.
number C. Joan, what would you like to take number C?
Yes.
Yes.
Let me take that.
Yes. How do you represent C?
That negative 5 is
I'm not hearing you.
that
Network quality is very poor. Can somebody else try?
I'm saying that negative.
Yeah, I can try.
I'm also trying. Yes, it is negative 5 less or equal to x less than 2.
Less than 2. Yeah? Correct. So it's negative 5 less than or equal to x, which is less than 2. So 2 is not part. Yeah? 2 is not part of the solution. Okay? And then finally E. Can we see E?
Yes.
E. E.
5 greater or equal to x.
Greater?
What's negative 5? Negative 4 is greater than
Let
negative
me
5.
let me try. It is negative 5 less or equal to x less or equal to 2.
Less or equal to 2.
Negative to 2. Yes.
So 2 is part, 5 is part. Now, if you're reading, Joseph, it's Humbert. You begin x. Always x is the one in the middle, okay? Because this is a solution between numbers, so x is in the middle here. So if x is in the middle here, you're saying this x here on the right hand side, you can't go beyond 2, isn't it? So you're going to say your x is less than or equal to 2 on this side. But on this other side, the same x, right? Ideally, the same x is greater than, but you can't mix greater than and equal to, so you will begin with negative. You will say now, this minus 5, right? X is in the middle here. So the negative 5 is less than or equal to x, which is less than or equal to 2. Okay? So that's how it will look like. Negative 5. So when you begin reading from this side, negative 5 is less than or equal to x. And then with your x again being less than or equal to positive 2. So now in this particular case, negative 5 is part, 2 is part. So that's why they are all shaded. Is that very clear?
Yes, sir.
Okay. So
Yes.
we have only 3 minutes left. So these 3 minutes, I want you to use them to write these equations. There is for number 3. So pick them, copy them out, and you solve these equations. The A, B, C, D, E, F, G, H. Yeah. So pick these ones. Pick these equations for number 3, which I'm highlighting number 3. These. So write them down. That is, you do that as part of your exercise for today. Is that okay?
Yes, sir.
Okay. So that's. Please write them out. Write them out. Write them out.
Should we put them in the graph or we solve them? This one.
Yeah, this is solve.
Number.
Yeah, solve, and then solve. After you've solved, you found the inequality, the x, for example. Let me give A as an example. A here, you just divide both sides by 3, isn't it?
Yes.
You will end up with x being less than or equal to what?
2 to 2.
No, it is x less than or equal to what? 3. Okay.
3.
Yes, so your solution here, the solution is x is less than or equal to 3. So on the number line, you represent that information. That means 3 is part, then anything from 3 to the left, okay, qualifies to be a solution. So you solve and then you represent them like this on number line as well, just to be sure that you have understood, okay?
Yes, sir.
All right.
So we are supposed to submit them on Tuesday.
Please do. I want to see them on Tuesday.
Okay, sir.
Okay, so copy them, and I'm ending in about a minute, so make sure you've copied this. Right, can I stop sharing?
I think we've written the questions. I think some other people are still writing. I'm done with the questions, so now I'm going to start the exercise now.
Just write the questions, the exercises for you. Write only the questions, and then each one does their. Yeah? Yeah. Okay.
Dharma, you're done?
Yes, I'm done.
Okay, so yeah, I'll leave it here. Thank you for the first trial of using Microsoft Teams. It's different from Zoom, but it's very interesting. It's nice. I like using it a lot. This is Microsoft Teams, so it's good to know the different approaches of having live classes. So Teams is one, Google Meet is another one, Caucus, so all those we can use in case one is off. We can always just use another one. Okay?
Thank you, sir, for your time. I was very worried. I was not enrolled, so I thought I would.
So I think you are the one who made Caucus to not to work, so that you can be on. You cannot miss. Yeah.
For sure, it was really confusing. It was confusing. I took almost my time working on it.
Sorry about that, but now you have it, so keep it there. So whenever Caucus is not working, we will be using this one in case we have a class which is online. All right.
Okay, thank you, sir.
All right, so have a good evening, and I'm going to stop here. I will see you people on Tuesday.
Okay, sir. Good night.
All right, good night.
Ciao.